All right. Good afternoon, everybody. We are back. So our plan is pretty simple to do four more experiments in this stream, and during the night we will do four more experiments. Right. So focus on the present. All right. So these control the number of ports opened by operating system with semaphores monitors programmed to illustrate concurrent execution of threads. Producer consumer problem using semaphores and following memory locations for fixed partition. Let's say using semaphores and monitors, we are supposed to do this. Let's do the minimal version and see if let's paste it over here. All right. This should be working out. This is a classic OS experiment, yes it is. Show me how the OS can limit the number of simultaneous accesses using synchronization. A port is just a shared resource. We are not opening real network ports. Okay. Semaphore. Suppose OS allows only two ports. There more than two processes try. They must wait. Semaphores keep a count. Wait decreases count and signal increases count. Okay, let's see. Semaphore beats red. Using yesterday semaphore representing ports. Mm-hmm. Mutex plus condition variable. Mutex thread. Yep, that is what I need. A port is a shared resource. Printer database connected, okay? Three processes want to use ports. Only two are allowed at a time. The third must wait. This is a semaphore. A counter that controls the access to a resource. If counter is greater than 0, process can enter. If counter is equal to 0, process must wait, okay? Wait decreases counter. Signal increases counter. Semaphore representing available ports, okay? Wide use port. Wide arc. In tiny. Okay, I have no idea. I have no idea what that syntax is. Semaphore functions, okay, page thread needed for threads to simulate declares the semaphore name report initializes semaphore a request a port release a post semaphore representing available port. I don't know. They can't some really simpler than this. Alright, semaphore. We must use threads here. Process All right. To run multiple processes at the same time. So empty is a data type, it represents the semaphore object. Got it? Every thread must run inside a function. This is the working of one process or thread window. Alright. A generic container used to pass data to thread. Threads accept only one argument. Pointer to anything. This is required by pthread. I see. Arg is a pointer. It points to an int passed from main. Treat this pointer as an integer pointer. Where did we see arg? I have no idea. If port is greater than 0, decrement it and allow that to continue. Okay. Same minute p share value. Create a semaphore named with value 2. Semaphore shared between threads. All right. Let's see if we understand anything, and if we got any more doubts, we will continue asking it. Okay, you need what is that one? UniSTD, yeah. Unique Standard Library. You need UniSTD, you need pthread, process thread, I assume, and you need semaphore. SIMD port. You got a port, and this is the syntax of the thread process thread void arg. Okay, I have understood that. Now you are getting the ID, dereferencing that. This part converts arg to int and dereferences it, alright? So after getting the ID, request port. So requesting is just printf, and sim wait and sim post are two functions. So this updates the semaphore value. Alright, after the wait happens, it gets port, sleep for some time. So simulating process. and then release the port. This is like a pair. Sim post. This is called by reference behavior as we see. If we want to make any real modifications, we need to give the ampersand. Like since we are giving the address, this update semaphore too, since it is a that returns a null value. Create a pthread. Pthread t pthread t3 and id3. So seminit is a function that initializes. Where is the port? Okay. 0 to. I need to understand this line and this line as well. For I is equals to 0 to 3, pthread create ampersand t of I. Okay. Now, okay, process ampersand id of I. Where the hell is id? Okay, I need to understand this one as well. And for 0 to 3, pthread underscore join t of I null. Right. The problem with this is, alright, I am completely new to this concept. So I think we need to go through some preliminaries. Like, what does the ID represent? What does the 0 in seminit represent? And what does the process function not actually do? And what is the null in pthread create? And I used reference of t of I to create the port and join. If required, we'll do some more basic programs before we get into this. We are not creating real OS processes. One program, multiple threads, and shared resources. Okay. is not ID. I meant port. Okay. Every thread must start executing in a function. So request support. Code for one process trying to use a port. Makes sense. Void arc. Cancel on this. Address of semaphore. Okay. Threads inside the same process. Okay, 0 and 1 are like on and off switches. Okay, got it. Semaphore is shared between threads, not processes. Thread ID attribute process where the OS stores thread ID. A create is writing ID, that's why. Got it. Threads cannot take integer only addresses. Got it. So it dereferences, that means you need to pass the reference. Nice. Oh my god. Why are you even going to semaphores without actually understanding what threads are? So we will create a thread first and then we will add semaphore. Yeah, this seems much reasonable. Okay, no. I think writing it is more important. Wait. I will write this first. Work function has an int id, print work done by id, call work 1, 2, 3. That should be enough. And similarly, work dereference it, dereference it, call work. How about, maybe make an array? Ampersand array of I. That is good. For 1, 2, 3, call them. Right? I mean, without having your pointers cleared up, how can you even expect doing something like this? Okay. This is 1, this is 2, and what is the third one? Now we are doing threads. Create a thread. Right. Without ports and all, firstly, void thread, let's say, void arg, just dereferencing, get the id of that thread, convert the argument to int, and dereference it. Got it. Print work done by id and return null. Right? And inside the main, what will you do? You'll create P thread T, T1 and T2, A and B. You create a thread. This is just a reference. This is actually creating, I think. Kernel work. This thread is going to do this work, and what is this ampersand? Let's get the third program clear. The work function is a general container that says what our thread is going to do, and thread underscore t, t1 and t2 are just reference to thread variables, and they are the process ID. Inside the pthread create function, we give a reference our thread variable, null is default, work is function, and a is reference to work is a general container that defines what a thread will do. Okay, every thread must start execution from a function. Pthread yes, they are references to thread variables. Okay. They are not always process-ID, they are user-defined IDs. Yes, they are user-defined IDs. Okay, that is passing over their argument. Okay, the thread argument that we wrote in the first function is coming from this pthread creator per function. Got it. So let's write the thread ID here. Thread ID attributes. Address of the value A1. Nice. It does not modify ARB. Got it. Got it. Main may finish first, yeah. Okay, I'm kind of understanding. Wow. Right. So, thread variables t1 and t2 local IDs, let's say. P thread create, this is a function, and person t1 null work ampersand a. So let's explain all of these. The general syntax is p thread create thread ID attributes function argument a1 goes as arg to our work function. This is understood, and null does not creates normal thread. Don't care how much tag size, priority, etc. That's it, and then you join the threads. Ampersand and create because ID is written. No ampersand and join because ID is red. This should be enough. And why is join? Join because main might finish before thread. For T1 and gets killed. To prevent that, join. Nice. We understood it, and then we will write the basic semaphore program. This is the semaphore, yeah. Okay, it is a semaphore. This is the work function. Sim underscore wait ampersand s. This is something between wait and post is a critical section. Okay. Pthread create and pthread join. Initialize the semaphore. Create the threads. Join the threads. You know what? We will do the threads and then we will get into this. I typed it wrong, didn't I? All right. Hey. This works. What are you doing? Doing OS lab, bro. All right. We'll complete this. So we will open this. Let's say practice.c. We will come from basic functions and pointers, and then we will do the other stuff. Right? So int work, let's say, it takes int id. And what do we do with it? Printer doing the work. %id. So just a basic demonstration of how the function is going to work. And inside the main function, let's create an array. One, two, three. These are the works. And inside that, we will call them. Work array of I. That should work out. For close and main close. Control X, Y. GCC practice.c output practice. Nice, doing work 1, doing work 2, doing work 3. I didn't put a backslash in. That's why it came out like that. Oh god. Nano practice.c. If I only put a backslash in over here, things would have worked out well. So now we will see some pointers. We will dereference whatever reference here and here as well. And now we will pass here with reference. So we can do actual pointer manipulation. Now what will we do? We will compile it again. Practice.c. Nice. It gave the same results, but we're doing in actual pointers. All right. Glad to hear, bro. What the? Yeah, glad to hear. Mm, we did one and two, and we will do three now. Nano practice dot C. We'll clear all of this thing up. Now, since we are actually creating some thread, we need to include the thread library. So what is the function of, what is the general syntax of void? A thread, creating a thread. Void, let's say work. It will take void arg. Generally, you can put any name in here if I am not wrong. So you will get the ID of the thread immediately. You will dereference it. You will convert it into int arg. So you will get your ID, and after getting the ID, what will you do? You will actually do the work. Doing the work of thread person d ID. That is a basic thread, and now inside the main, what will you do? You will create thread variables thread underscore t t1 t2 and some IDs a and b. So pthread create. It takes four parameters. What is the first one? It takes the thread ID first. And what is the second one? The default type null. And the third is the work function. And the fourth one is, I'm doing this without saying by the way, and the address of the ID that will get passed to the work function. Pthread underscore create. It is going to be ampersand t2 this time. Null work ampersand b. We created the threads, and now we will join them. Pthread underscore join. We'll join the thread. The default is null. It is void, so there is no return value. Okay. This should work out. Thread.h. There is no library like that. What do you mean? Pthread.h. Very good. Pthread. What does pthread underscore t might be? It might mean create. Okay, so pthread. Wow. The classic developer time. Did you mean pthread underscore? Pausing argument. Well, we need to compare the code, I guess. I mean, for a 10 line error, for a 10 line code, we got a 100 line error. Wow. Right, work void arg. We got the integer and we are doing some. Okay, this thing need to return something, even though if it is void, it need to return null. What if it isn't? What if it doesn't return null? We will see that. Okay, it's not create. Yeah, that is the only problem that this guy had. That is the only problem. Let's ask this. I did not write return null in the end of the function, and it shouted at me. Is it that important? Anybody's here? Thanks, bro. All right. Yes, it is important, but it is not the only problem you have. Really, your thread function must have this exact type. The function returns a void. It must. Yeah, your work function is like. Is that void star that important? I mean, what would be the difference? Void is mandatory. Pointer to anything, it is generic pointer. Okay, that makes sense. Void, it is a pointer to anything. Since we are not pointing to anything right now, we are giving null at this moment. Okay. The pthread library designer said we don't know what data type users want to pass to thread, so we will accept a pointer to anything. This is not a suggestion, this is a contract. Okay. I think it might take some time for us to, get the syntax. Is it pthread tree? He wrote thread T, right? ChatGPT wrote thread T, I swear. He wrote pthread T. Okay, I did not see that. Very good. The library is pthread, so why would it be thread? It would be pthread. Okay. 16 lines, 10 errors, whatever. That is how you learn anyways. Ah, okay, it compiled. Thank you. Okay, that is enough, man. Right. So now we will actually do the semaphores. Finally, I got the output now. Let us actually do the semaphores. Yeah, I think all of this is necessary. Right. Threads can run freely, all can point at the same time, no control. But we only want a limited number of threads can enter the critical section. Others must wait automatically. This control mechanism is a semaphore, an integer counter managed by the OS, so you cannot write int semaphore. Got it. New things you will see. Semaphore.h. Okay. And semts. Okay, that is a semaphore variable. Sem init, sem wait, and sem post. That's it. Initialize the semaphore by giving the address of the semaphore variable and 0 shared between threads and 1 only one thread is allowed at a time. Two threads are allowed. Got it. Enter may block exit makes next. Wait and post. You make a semaphore variable wait and post. Okay. So this is a thread and it is a global semaphore variable. This is common. This is thread requesting. After that wait, and after this line got completed, it will get the port. It got the port. Okay, you can use this as well. I see. Maybe sleep for 3. That should be enough. So to use sleep, do you need any other library? We will see that. After releasing wait and post, you will create p threads and you will create the local variables. Right. This laptop is legit frying now, dude. And now only one port can access at a time, and you will join everything. Nice. So do we have the producer consumer problem after that? Okay, we should be able to do this and this one too, as this guy is saying, because we had built enough basics and memory allocation methods. Okay, we need implement, not just simulate. I see. We will see that. How many minutes are we in? Just 1 hour. All right. We still got a lot of time. I cannot believe people are actually watching my stream. Like most of the times, I will bet 0 viewers. And thanks for watching the stream, people. If there are any, right? Let's write this first, and then we will continue. Now, what is this one? Okay, we did threads, and now we are doing semaphores. Have the stdio. You obviously know that p thread and semaphore libraries. You need to have them. And sem underscore t. I guess semaphore thread it might be. Maybe. Write the work function void star work. Sorry, void arg. You know all of this. And now what will you do? Int id is equals to nice. I wrote it without seeing actually. And request port same underscore wait. It will make the what will it make? Yeah, it will make this wait and then sleep 3 seconds maybe and then release port and then alright same underscore post ampersand less. That's really it. That's really it. Okay. Most of the times I used to think like null means nothing. I used to think like zero. Then what is the point of actually writing null? I used to think like this. So it comes very handy in pointers. Yeah, the more you do, the more you're going to understand anyways. Okay, now in the main function have threads p thread t t1 t2 t3 and maybe you can have int array as well 1 2 3 having local IDs. Yeah, he did this but that's not mandatory. Initialize semaphore. So that will be sem underscore init initialize. You are initializing semaphore. Now the important thing is 0 means shared among threads. And 1 means number of ports it can access. They can access concurrently. Nice. And create all of the threads. Create all three. Join all three. Done. Done. That's it. That's really it, people. Right. Wait. I just clicked at the rate of and something happened. Yep, this one. So should we post this as official? Let's remove this. Which one? Practice rm practice.c. Yep, they got removed. Nice. We had two sample txt files, experiment 1, experiment 2 and experiment 3. So now all we need is experiment 4.1. So nano experiment 4.1.c. Nice. So let's write it. I'm using another keyboard and it is making me press other keys. What do I do? Yeah, this, I guess this is the proper alignment. Pthread dot h and semaphore dot h. Now we are making a global semaphore variable sem underscore t, yes. And now we are creating the work function void work void arg, and inside the work function, what will you do? You will get the id arg. Now you got the id. Now what will you do? Request the port. Printf process %id requesting port id. Now what? You need to wait and post. So sem underscore wait ampersand s. You will make this wait semaphore variable. And now to simulate time, I will make it sleep for 3 seconds. And then process %t release port, okay. Being released, you can write it id, and now post. Okay. Return null is important. We saw what happened if we did not write that. And we will write the main. What will we do in the main? We will create semaphore. No. Pthreads. We already created semaphore. T1, T2, T3. And we will create IDs. The ID is local to that, right? So that should not make any difference here. Now what will we do? You need to initialize the semaphore. You need to initialize the semaphore, right? Some wait and some post goes there. Initialize the semaphore. So ampersand is obviously 0 shade among threads, and let's give 2 processes access at a time. So for that we need to increase the number of threads. Maybe we will understand if we increase the sleep time. Okay, 10 might be too much. Let's just do 5. Now pthread underscore. Okay, you can write a loop for this, right? For int I is equals to 0, I less than 3, I plus pthread underscore create. What will you create? It takes 4 parameters. Oh, you cannot write it. I mean, you can write it t, but it will be abusing the logic. Never mind. Pthread create ampersand t1 and null is data type, and what is the work? Work is the function. ID of 1, let's say. ID of 0. Okay, you need to pass it like this. ID of 0. No. No. Oh my god. Oh my god. Hate this keyboard, man. Ah. Okay. Everything is same. You are creating, and that thing has a semaphore over there. And now you need to join T1, null, pthread underscore join T2, null, pthread underscore join T3, null. And now since it is void, you can just close it without returning. Yeah, this should work out. Let's pray to God that it is going to work out. Okay, practice does not exist, my bad. GCC experiment 4.1.c output 5 experiment 4.1. It is only a semicolon. Okay. How did it got deleted? Huh? Whatever. It's 4.1, not 3.1. Alright. It is a semicolon. Control X, Y. Alright. Now what? Sleep. Implicit declaration of function sleep. Yeah, that's what we thought. We need any libraries for sleep. Yeah, you do UniSTD. POSIX function, okay. So including UniSTD every time doesn't hurt, it seems. Now let's again recompile it. Nice. It compiled, oh my god. Okay, nothing's happening. Oh, wait. Process 1 requesting. That is not the expected behavior, right? It printed all of this at a time. After some time, thought we are going to see prints after the other with some weight in between. Certain time that. Hmm. Yeah, I expected like that. Standard out is buffered. Okay. So you just need a new line. I see. It is a Linux behavior. GCC experiment 4.c output file is experiment. Nice. Why is it printing two times, huh? Wait, that is not what I wanted. Oh, you never changed array of the. You never changed that. Wow, they are the, you know. Oh, I messed up over their movements. See, the ID is. Oh wait. It is ID of 0 everywhere. Copy pasted and forgot to change. Nice. We figured out an error by ourselves without asking ChatGPT. Nice. Nice. That is what I expected. And that is what we got. We coded semaphores, dude. We coded semaphores. Nice. That worked out. We coded semaphores. So now let's code monitors. Just a second, people. All right. Yeah. Let's continue. Hmm. What is a monitor? Monitor is only one thread. It is allowed to touch a sheet at a time. Monitor is just a rule. Only one thread is allowed to touch a sheet at a time. And threads can wait safely in a condition if a condition is not satisfied. Okay. Semaphores contain controls how many can enter. Monitor controls how they enter in an organized way. So you do not have built-in monitors. Mutex plus condition variable. This is standard, accepted, and expected. Mutual exclusion, waiting, and signaling. If not available, thread must wait. When port is free, wake one waiting thread. We manage the count ourselves. Okay, ports. Okay, you do not need to include semaphores because you are doing monitors, obviously. Ports 1, pthread, mutex, T, mutex. Okay, this is general thing. Pthread, mutex lock. Mutex, enter monitor. While ports is equal to 0, condition not satisfied. Okay. This is alright. We need to have a lot of preliminary information before doing this. That's for sure. Before doing this. So, what is monitor in general? It gave a single line statement, but it did not make sense. Why do you need monitors when semaphores exist? And what are these two new variables? We introduce new text and conditional pthread mutex lock. What does it do? And what is the while condition for port a flush pthread conditional wait pthread mutex unlock I need to know every new function if necessary. We will do some preliminary programs. What are we building? We are not building anything, bro. We are just doing waste labs. Wait. I'm typing every reply because some people might go and they might come back after some time. Then they might see the reply. They might not be watching my live when I answer. That's why. Okay, it wrote the answer. Wait. You're absolutely right. Before writing monitor code, the conceptual ground must be sounded. Let's forget the code for a moment and build the ideas from scratch, like a nice textbook, but in simple C programming language. A monitor is a high-level synchronization construct. Do you need to use these big words, dude? Okay. Only one process can access a shared data at a time. Processes can wait safely until a condition becomes true. Let's make that make sense. Let's make that make sense. Okay. He's becoming good at wording. There is one printer, most people want to use it. Only one person can use the printer at a time. If printer is busy, others must wait. When printer becomes free, one waiting person is notified. Nice. If people follow these rules automatically, you have a monitor. The shared data, printer, port, buffer, etc. You can't misuse it easily. That's classic voice question. Semaphores are powerful but dangerous. You manually call, wait, and signal. You can forget to signal, yes. You can signal too many times, yes. Because everything is at the end depending upon a variable, sem underscore t, right? This causes deadlock. So semaphores are row level, flexible, but error prone. We don't want deadlock, so we are using monitors. Enforce discipline, like a class monitor. Mutual exclusion is automatic, waiting happens only via conditions. Structural programming. Okay, semaphore is part of that. Nice. This is a movie dialogue. You manage synchronization, synchronization manages you. Mutex mutual exclusion, only one thread enters a critical section at a time. Bathroom door, okay. Lock enter, unlock exit. If someone else is inside, you wait automatically. Yeah, I need to get some water. I will take a break after this. Pin thread mutex lock. I want exclusive access to shared data. Okay, we are applying a mutex lock for a share for a thread. Nice. I am done. Someone else may enter. Mutex ensures one thread enters, but what if thread enters resource is not available? It should wait, not busy loop. While ports is equals to 0. You need to sleep until condition changes. Wait. What is? Okay. But what if thread enters, resource is not available? It should wait, not busy loop. Let's see a condition variable. I cannot continue until some condition becomes true. Please put me to sleep and wake me when it changes. This is safe waiting. Uh, it does three things atomically. Reduce the mutex, put the thread to sleep, reacquires mutex when woken up. Release the lock and sleep until someone signals me. Okay. While condition is not true, thread may wake up without condition being true. Spurious wake up. This is not monitor related. Printf output is buffered in thread programs. Output may appear late. Flush standard out. Write on the mutex program. Write on the condition wait. Let's do step A, B, and then See, it worked for me with semaphores, so it might make your learning curve easier too. So I got two more main doubts. They are, what's the first one? What is the need of conditional variable exactly when you have mutex lock? Like, I can't understand their individual functionalities. When I read about mutex lock, felt that is enough. And what is the second one? The second one is printf with backslash. Wait, don't go. I clicked in enter. Oh god. Oh god. For backslash, I clicked enter. Anyways. A mutex log is only one question. Who is allowed to enter in a critical section right now? It does not know whether the work can be done. A conditional variable answers a different question. Should the thread continue now or should it wait until something changes? Waiting based on a condition, it controls progress. It lets threads sleep instead of wasting CPU. Okay, waiting room with a bell. Got it. Pthread mutex lock if port is equal to 0. What should a thread do if port is equal to 0? Stay inside mutex and wait. Blocks everyone, yes. Unlock mutex and keep checking. Busy waiting, yes. Sleep and wake up when ports change. Nice. Busy waiting. We don't want busy waiting. We don't want to enter unnecessarily. So we need a condition. Okay, you only enter into an office when the calling bell is clicked in the waiting room. Nice. When to proceed, alright. What is the deal with printf? No, I didn't. I was writing my second out and I accidentally clicked enter. So my second out is my printf with a backslash n is working fine. Why do we need a flush like printf won't work in monitors like it worked in semaphores. On 41, right? We are still here. Oh my god. Printf does not directly print to the screen, it prints into a buffer. Memory buffer to terminal. Here output is told, okay. Output terminal. Standard out is line buffered. Got it. Timing was simple then. Force everything in the standard out buffer to be written now. Got it. Okay. Nice. Let us experiment it. Because why not? Wow, I didn't know that until now. Yeah, you need uh, to use sleep, you need uni STD. Let's printf. Hello. Nice. Oh, okay. I messed up the practice spelling. Nice. Nice. RM practice. So, if you have flush here, wait, where are we? A flush STD out. Nice. And now what? Oh, my bad. Hello. Hold. Good. Good. It is working out. RM practice.c practice. Okay. We were lost in concepts. This is what? This is semaphore example, alright. This is enough for monitors, right? We had p thread, mutex thread, mutex. We had conditional thread, conditional, and port is declared globally. Let us declare it as 2 and lock the mutex. Where is mutex? Okay, this one. You are locking the mutex first. While ports is equals to 0, process is waiting for port. Conditional wait. Decrement ouch. Ports. Process got port. Got it, got it. So process waiting for port prints a lot of times, if I'm not wrong. After got the port, you unlock it and you make it sleep. And you again lock the mutex and you increment it. Okay, what? So, regarding the process and the monitor function, we locked the mutex immediately and you said something about not using if but only while for condition. Why is it? Can you explain in simpler terms? And I think while prints process one waiting for port as long as and as many times as the process waits. And we unlocked it. If I already checked once, why checking again? Waking up does not mean condition is true. You are waiting for a classroom to be free. The watchman says, I will call you when it's free. Watchman accidentally calls you or calls many or calls you, but someone else enters first. If room is free, enter, you might You might enter even though it's not free. Okay, this is a perfect analogy. This is really a perfect analogy. Continuous checking until the thread enters is important. P-thread conditional wait means someone signals something. It does not guarantee the condition you want now is true. So always recheck condition after waking up. No, not continue. It prints once per wake up attempt, not in a tight loop. Because inside the while you call puts the thread to sleep, it does not spin, it does not loop fast. Okay. Yeah, you locked and check condition, unlock. Oh my god. I mean, he wrote it as a B part, not even a complete program, but there is a lot to learn in one experiment only. Wow. P-thread conditional wait. Unlocks mutex, put that thread to sleep, relocks mutex when waking up. Lock only while checking. C makes you write mutex conditional while loop. Yeah, the semantics are same, but they are hard. The syntax is harder, man. Yeah, we have read a lot, and let's see if we now understand anything. We have both. We have mutex. We have mutex lock, and we have a conditional variable, whatever it is. And we had a thread process, the ID, and we locked it while ports is equals to 0. Okay, process is waiting for port and immediately print it out. And conditional, wait for the condition. Okay, after locking, if this is the case, print the port, decrement the port, and okay, this ID is different and the below ID might be different. And after getting the process, you are unlocking and sleeping. Okay. Wow. This is something, man. This is something. We're almost down to 2 hours and we did not even complete two programs. Whatever it is. I wanted to take a break right now for some time and I will be back. Alright, people, I will be back and see you in like an hour or something. Yeah.